Hey everybody, in this video we're going to be working with trigonometric indefinite integrals. If you want to follow along, the links to the companion worksheet are in the description below. Also, don't forget to click that subscribe button so you can stay up to date on all the videos that we have coming out from the channel. So let's get started. Now when we're finding an indefinite integral, we want to find an antiderivative. That is, we want to look at the expression and ask, well, what would produce this as a derivative? What would produce this? Now, if you're familiar with the rules for trig derivatives, you'd know that, well, the derivative of sine is cosine. So that means the antiderivative of cosine is sine of x. And the derivative of cosine is negative sine. So that means what would produce sine as a derivative? Well, that would be negative cosine of x. Because when we take the derivative of cosine, the sign changes, but not so with sine. Now, this is not our final answer because there may have been a number, a constant, that was there added on the end of it. And when you take the derivative, it disappears. So anytime we have an indefinite integral, we always take that into account. So you'll often see a plus c somewhere. And that's just a stand-in for whatever the unknown constant is. Now, looking at the second one, we have this indefinite integral, tangent squared x plus 1. I don't know anything that produces tangent squared as a derivative, but this, if we remember our Pythagorean identities from trigonometry, this right here is equal to secant squared of x dx. And so we can just replace this with that. And by doing that, we can say, well, wait a minute. What produces the secant squared as a derivative? Well, that is going to be tangent of x. And like the above one, we're going to remember that we include the constant. So it's tangent of x plus c. So on the next one, here we have sine over 1 minus sine squared. Well, this is another example of a trig identity, and that is, this is going to be replaced by cosine squared of x dx. And what we can do is we can break this up into sine of x over cosine of x times 1 over cosine of x dx. And we can simplify that to tangent of x times secant of x dx. And so what produces a derivative of tangent or secant? Well, there is no one function that produces tangent as a derivative or secant as its derivative. But there is one trig function that produces tangent times secant as its derivative, and that's going to be secant of x. So if we were to take this derivative, we would end up with this expression, tangent of x times secant of x. But as before, we can't forget, it's going to be secant of x plus c. Now for our last one, here we have secant of x times tangent of x minus secant of x. And what a lot of people get wrong about indefinite integrals is there is no product rule for antiderivatives, which means what we have to do is we have to take this and multiply it in. So what we're going to get is we're going to get secant of x tangent of x minus secant squared of x dx. And as before, we saw that what's the antiderivative of secant x tangent of x? That's going to be secant of x. What's the antiderivative of secant squared? Well, that's tangent of x. Now, not tangent squared, just tangent. And the derivative, if we were to take the derivative of this, we would get secant squared from tangent, and we would get secant tangent from secant. And don't forget, we have to remember to add the constant on the end. So, thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.